Hello, ladies and gentlemen. My name is Cathy. I'm here to talk to you about plate tectonics. Today, I'm here to answer 3 questions. What is plate tectonics? Who discovered it? And how does it work? So, what is plate tectonics as an academic topic? Plate tectonics is a scientific theory which describes the large-scale motion of different plates moving throughout time. In modern understanding, we believe that tectonic plates are the lithosphere broken into pieces, big and small. We also know that these plates may move throughout time and ends up the way the world looks like now. We also believe that 3.35 to 1.75 billion years ago, the world were one big continent called Pangaea. We also know that these plates move because of the convection currents below. So, how exactly we come to this place knowing all this? Well, we need to go back 50-60 years ago. In 1912, a meteorologist called Alfred Wegener discovered the idea of continental drift. He stated that all the continental plates we have now have all moved throughout the centuries and ended up here where they are now. He says that billions of years ago, all of the plates are together as one big combined land, like a huge puzzle which all fitted together. Before Wegener's theory, the common believed idea was that the plates may have moved, but wasn't big moves, just small moves caused by natural hazards, like floods or earthquakes, and nobody believed that there was once one gigantic land named Pangaea. Alfred Wegener also came up with mainly 4 evidence which support his idea. 1. Many identical animal fossils were found on the 2 sides of the continents, which are now far separated. This proves that the same kind of animal lived on these 2 sides, which could mean that the plates were conjoined. For example, Lystrosaurus fossils were found on the Bay of North, South America, and West Africa. Lystrosaurus was a freshwater creature. It's unlikely that it swam through salt ocean to the other side. He also discovered that some cliffs have the same geological structure, and that was very uncommon, unless they were together and broken to half. This suggests that these cliffs matched together and were once conjoined. It was explained that places had unusual traits of extreme climate. For example, in Brazil, South America, traces of ice movement had been discovered. This means this land was once near the North or South Pole, but of course the continent now is one of the warmest, so it must have traveled. The last evidence is that the shape of the continents all fits together. What a coincidence! However, Wegener's theory was not trusted by distinguished scientists such as Howard Jeffreys and Charles Schonchert, and so wasn't popular. But during the 1920s, 1930s, and 1940s, the theory was proven and agreed, even explained or improved by several scientists like Vinnie Minez, Arthur Holmes, and Grove. They explained that the drift was caused by convection currents, and in 1950s, an idea called polar wonder was introduced. By 1965, the idea of continental drift was then popular. After explaining what plate tectonic is and describing who discovered it and its history, let's start answering our 3rd question. How does it work? So let's look at the forces that drive these plates and drove geologists crazy. The most commonly explanation is convection currents, which means magma from the bottom rises as its temperature increases and cools down on the top, then sinks back into the cores. This is convection currents, which happens in the mantle. Busy scientists didn't just stick with one explanation. They also said things about rotation of the Earth, which may attract the plates to move with it, tidal forces from the moon and the sun, and possibly gravity, which appears in destructive margins. Destructive margins? What's that? There's three kinds of margins which are caused by moving plates. The first one, conservative margins. Conservative margins is when two plates move sideways, each in a different direction or at a different speed. As they never really move smoothly, earthquakes are very likely to happen. An example will be the San Andreas Fault in the US. Moves on to the second one, constructive margins. These margins appear when two plates move away from each other. When they move, a gap in the middle is created. So magma, which is waiting impatiently at the bottom, will rise and create volcanoes or mountains. A famous example will be Himalayas. And finally, our destructive margins. This occurs when plates crush into each other. An oceanic plate, which is more dense, will sink into the core by slab pull and trench suction. Slab pull is when gravity pulls the oceanic plate in, and trench suction is small currents behind it which help it to get down. This may cause earthquakes and volcanoes. An example will be surroundings of Japan. In modern days, we have 6 big plates: Eurasian, Pacific, American, African, Indian, and Antarctic. Eurasian the biggest, and Indian the smallest, and each very unique. Throughout the years and countless geologists' sweat, we know and learn about their achievement. Here, I appreciate what science did for our modern day knowledge and certainly hope that in the future there will be more discoveries. Thank you for listening.